Hi everyone. In this tutorial, we're gonna discuss about Latin square design using the ExpDes package. If you remember, in the previous two tutorials, we tried to discuss about the completely randomized design, randomized block design. Again, today we'll continue the Latin square design using this package. So as usual, you have to import your data. I already imported the data in order to save our time. And the data structure is look like this. Here is the column, here is the row, here is the treatment, and the last column represented as a gradient, or it's our response variable or dependent variable. And the column is the vertical blocking, while the row is horizontal blocking. And there are five. So if you know that the if we have five treatments, as you can see here, is our treatment is A, B, C, D, and E. So this means that if we have five treatments by default, the number of column as well as the number of row is equal. So we will have five rows and we will have five columns, and the last one is the response variable. So in order to use or in order to compute Latin square design in the ExpDes package or experimental design package, you have to use the latsd, which stands for Latin square design, and it's followed by the parenthesis, and under the parenthesis the first is a treatment that contains our treatment column, maybe for its genotype or special, whatever it is. So the first is represented or designated by the treatment, and followed by the column that contain the row, and again followed by the column that contain our column or vertical blocking, then followed by the response variable that you have. So in our case, we have gradient. So it will be GY, which stands for gradient, and it is the found in column 4. These are the response variable. And then here is quali, means it is the short form of qualitative. That means qualitative is equal to true, means you are telling to R, or R will assume that your treatment is qualitative instead of quantitative. So qualitative is equal to true means so the R treatment is qualitative. That's obvious because here is B, A, E, D, and C are qualitative. They are not numerical. Then it's followed by the mcomp. Mcomp is equal to the mean separation that you want to do so. For example, here is SN case, means student Newman Careless test. Maybe it is the least significance test, maybe it's Take, maybe it is Duncan. So whatever it is, it depend on your objective or depend on your selection criteria. You can set the multiple comparison. But one thing here, if your treatment is quantitative, so the multiple comparison will not be displayed. And if your treatment is a qualitative, linear regression is not formed. So this is some additional knowledge. And if you remember in the previous tutorial, we checked the assumption using the Shapiro test. Again, we also check the homogeneity of variance using different methods. Yeah. But under such circumstances, only the multiple comparison will be displayed. But again, only the ANOVA assumption of normality is performed, but the assumption of homogeneity of variance will not be checked when you are using Latin square design in the experimental design package. Then the significance, it is obvious. It is the level of significance when you are comparing, when you are computing multiple comparison, and the significance F means it is level of significance for the ANOVA F table. the default is 0.05 for both cases. So type this and submit to our studio. So let's see the result. So obviously in the latsd design, the sort of variation is treatment, row, column, and it's 3, as well as error is 4, while in the case of CRD is 2, one is treatment and error, and in the case of randomized complete block design, the treatment, blocking, and error are the source of variation. And except a column and all are statistically significant. You can see here in the p-value is less than 0.05. Even there is statistically highly significance among the treatment. Then here is a coefficient of variation which is called 11.77, and here is the assumption of normality is not validated because the p-value is greater than 0.05. So when assumption is not significant, that means that particular assumption is not violated, so it is safe. So according to the Shapiro, we will the Shapiro-Wilkes normality test, the p-value is 0.32. So we are conclude that we are going to conclude that there is a normality among or residual can be considered, and there is no assumption of homogeneity or equal variance on this test. So the limitation of competing latsd design in this experimental design, you are not going to see the assumption of homogeneity variance, but you can perform using the Bartlett and Levin test and any other techniques for checking homogeneity variance. But I'm telling you only on experimental design package. Then here is the mean comparison that I'm used is student Newman scales test. So treatment A, treatment C, and B are not statistically significant since they are shared. B since they are sharing the letter B. So when letters are shared by the same groups, so they are not statistically significant, while treatment D and E are not statistically significant each other, but they are different. They differ from A, C, and B. So by this way, you can write or you can summarize your result. So this is all about today's tutorial regarding to latsd design using the experimental design or ExpDes package using our software. Thank you for watching. Have a nice time.